Next, I'd like to welcome Kyle Bartfay from Phoscrete Industries to talk about the ITD, or Innovative Technology Development Program.
Good morning. One thing I've been listening to, and there's a theme this morning, it's about communication to promote efficiency, and we're going to continue with that theme with the ITD program, to continue it to improve communication, to improve innovation. Raise your hand if you are part of an agency here. Raise your hand if you are part of industry. Awesome. So if I can summarize this in a nutshell, it's to give the industry people who are paid to talk about how great their product or service is, since the greatest thing since sliced bread, to you guys who are paid to make these decisions regarding bridge preservation. Today I'm going to go over the ITD program and then also discuss MWBPP technology, which is Phoscrete's as a pilot program, and then David from Jet Filters is going to get into it as well. It was really evident even, yesterday I was talking to someone from agency who had never heard of Phoscrete before. Once someone else came up that was familiar with Phoscrete, that has been using it, said how great it was and how their experience with it, it automatically gave me credibility to that person, and this is what the idea of this is trying to do. ITD stands for Innovative Technology Demonstrations. 5 years ago, following the lead of the TSP2 Pavement, the Bridge Group formed a national working group called ITD to launch this pilot program. Followed the 2014 national meeting where the industry field demonstrations were so well received, and the goal is to take these demonstrations out into the field where owners can observe new and innovative products in the real world environment, and not just a demonstration. So some of the problems that we run into is incomplete documentation. I've been on a bunch of job sites where the deck is full of bubblegum patches from different products over the years. Some are holding up, some others aren't. But nobody did a good job documenting all the repairs and following up with all the turnover and all the time, so nobody knows what is working well and what it may not be working as well. The bias, as a manufacturer, I'm happy to show you 10 case studies where the product was successful, but just like my resume, I'm not going to give you references for where it didn't perform so well. One strike, you're out. Typically, if you are trying to bring a new product or service into the field and it doesn't perform as well as you would like, typically you're pretty much dead in the water in that area. So the idea here is to show if it works in 9 times and the one time it doesn't, you still have the credibility to give it another shot. And then the other problem is lack of interagency communications. Typically I try not to read my slides too much, but I think this is good to read. Because of all the complexities and risk involved in bringing new products and services into acceptance and the use by states, ITD offers a fast path to demonstrate, observe, document, and share both successes and failures of innovative technologies. ITD helps industry speed the best solutions to market and saves the agency the cost of wasted time and resources on unsuccessful technologies. So here's some key points, and again, this is a joint effort between the DOT and the product supplier. Field demonstrations are necessary and must be documented very well, which I'll get into in a minute. And then rigorous independent oversight for up to 60 months. So it's important to not only document the actual installation, but also document how it performs over the months and years after that product or service gets installed. And then the results will be vetted through the TSP2 ITD working group. So there's a couple partners, there are players involved here. You have the manufacturer, you have the consultant, the owner/DOT, the TSP2 bridge, and then academia, which we're getting more involved with this. As the manufacturer, installation support and consultant fees are paid by the product or by the manufacturer of the product or service provider. Keeping track of the installation and arranging for follow-up inspections is also the responsibility of the manufacturer working with that owner. An independent consultant, and this is what I think really sets the ITD program apart because it's going to give it an objective viewpoint. Thanks to the independence of the consultant, ITD lends a high degree of credibility to the data from multiple installations when presented. And then the owner commitment, there's an upfront contract that the owner will agree to perform those various inspections at the time frames that is discussed before. An agency can volunteer to participate, including state DOTs, municipalities, federal, military, restoration contractors, commercial maintenance staff. Volunteer agencies are responsible to purchase the MWBPP material, in Phoscrete's case, and provide traffic control equipment and labor to perform the repairs. The owners can also, if they're doing something unique that other bridge crews or other people are not doing, they can also apply for the ITD. I was in New York a couple of months ago, and they had a very interesting way of controlling their vegetation. They actually got a bunch of goats, and they used that. They ate the vegetation instead of doing all the mowing, and it actually got them a lot of positive publicity for the DOT. And they're thinking about applying for goats. So it could be anything, thinking outside of the box. TSP2 Bridge approves the participants, has oversight over the program, publishes data, and gives presentations like this, and it also goes on their website as well to see the documentation. Academia is consulting, inspection, data review, and presentations. A lot of people in the academia world are being used as the independent consultants that I was talking about earlier. Demonstration and reporting. Demonstrations can be a product, service, and or equipment for bridge preservations, or GOATs, like I said earlier. ITD reports to be a resource for DOTs and other bridge preservation practitioners, replaces inefficient, non-rigorous evaluation of pilot installation deployment of innovative products. So it's pretty easy to apply. I think it's on the TSP2 website, just a 2-page application, whether you're on the DOT side or the manufacturer side, and we can get that program, or we can get you signed up for that. Foscrete has been fine-tuning the ITD process over the course of the past 3 years, and most recently we worked with DOTs across the country to fine-tune a process where an expansion joint can be repaired, both header and the seal, in one shift. The advantages to the contractors, the agency, and the driving public are significant in terms of saving time, money, and minimizing traffic control, doing all this in one lane closure compared to 2 in most cases. So a little bit about MALP and the MALP technology. It's traffic ready and or sealant ready in 30 minutes. It's easy to mix, place, finish, and clean up. Has a chemical bond to concrete and phoscrete and metal, so there's no cold joints. It works in sub-freezing temperatures. It's naturally corrosion resistant, and it draws it in. And it does not shrink or crack. Once phoscrete kicks, the reaction goes very fast, allowing for rapid opening to traffic, and it can also immediately accept coatings and can be diamond ground for maximum rideability without the need to make a second trip to the installation site. We reach about 75% of our ultimate strengths in the first 3 hours, so it works very, very quickly. This was the first ITD program that we did back in 2014. This is in Massachusetts with MassDOT, showing how we are able to do patching in sub-freezing temperatures. I believe the temperature here was in the teens or the 20s, and we're still able to open up the traffic in 30 minutes or less. So this is the 2014 on my left, and then this is the inspection 4 years later, still holding strong. This was a MALP, this particular one is a MALP overhead project with Oklahoma DOT. It's a packed saddle bridge. 47 pails of our phoscrete vertical overhead was installed with no sandblasting and minimal prep. Installed by the ODOT bridge maintenance crew. On the left is the before picture, and then on the right is the inspection 2 years later, still holding strong. And you can see how corroded that rebar was, and we were able to essentially reverse that. This is another a project with Oklahoma DOT with shotcrete. It's overhead. This was actually just happening earlier this year. It happened in April, and the inspection 3 months later is on the right and still holding strong and sound. And this was installed by Restec, which is a contractor in Oklahoma. This is our expansion joint header and seal. This is the done-in-one that I was talking about. Typically with a lot of header materials, the cure time is anywhere from 2 to 4 hours, depending on the weather. With Phoscrete, we are able to install the header, and 30 minutes later, grind it and install the joint seal in the same lane closure. And then I will give it up to David, and he's one of the newer products in the ITD program, and he's going to explain his experience with it.
As Kyle mentioned, jet filter system, we're in the middle of an ITD project on a box culvert with Michigan DOT. I'm going to get into our role and how the ITD project is good for us as a company, share something about the preliminaries with the project. Before I do that, I would like to share a little bit about maintainable weep hole filters and the concept, because this is a relatively new concept for many people. When you have a retaining structure, you have to deal with the drainage behind the wall. Over time, performance starts to degrade, could fail, water starts going somewhere you don't want it to go, could be taking soil particles. You can go through and you can plug holes, you can patch the walls, you can do some temporary fixes, but if you really want to fix the drainage, you probably have to excavate. Take out the old drainage system, put some new drainage system. So it's a significant amount of work. So the concept for maintainable weep hole filters is how can you do it quickly, cost effectively, without excavation? So the solution is very simple. A unit slides into any new or existing weep hole. That's preliminary filtration. And then the geotextile filter fabric is in a removable, cleanable cartridge. It can be pulled out at any time, inspected, brushed off, or replaced. Can't do that with any drainage system behind the wall. Another benefit is if you want to replace this, if you figure out, well, you know what, I need a different filter fabric. You can just pop this out and pop a new one in. So it's a really innovative idea that got its start in seawalls and bulkheads. Marinas is used quite a bit in Florida along coastlines. Comes with a one-way valve for water applications. Retaining walls, drainage canals, bridge abutments, dam spillways, even underground parking garages and other underground structures, and box culverts. And I know there's other applications we have, like tunnels and stuff, but these are the main ones that we get involved in. Our product's been out for a while. It's been used extensively, but it's very unknown. And as a new company with a new product, that doesn't fall into any category. So in working with AASHTO, what category is a weep hole? Well, there isn't one. So our challenge was, how do we get this approved? How do we get this out? How do we get it in front of organizations? In working with AASHTO's APEL group, they tried to identify, well, what testing should we do? We could just go out and do a bunch of testing, but what's the testing that needs to be done? And what standard format is a maintainable weep hole filter supposed to follow? So their guidance pointed us to the ITD program. And for us, this was a great opportunity because we could get real life, although it's been installed, we could get our products into a DOT, get an engineer to evaluate it, to get a long-term review and evaluation of the product, and get it published. So we can get some credibility with the product with AASHTO. So our project with the Michigan DOT is a box culvert. It's 172 feet long. It was built in the 60s. It originally had weep holes, and over time, those had failed, and they had gone through and soil was coming out. They were getting sinkholes, partially because this was a high-pressure situation. On both, all the water was flowing against this wall and against this wall, and along Lake Michigan, there's significant amount of snow and rain, so it was always had water above it and all the way up the walls, leaking through cracks, coming out wherever it could find a place. And so over time, those had been plugged, and then more fines and particles were coming out through the ceiling, through the walls. Lots of cracks were forming, so they had to have a solution. They also had another problem where the amount of erosion that had taken place underneath the existing weep holes was significant. So some of the locations where they had weep holes could be reused, but other locations had to be moved because of the water damage. They came in and cored 4-inch diameter holes. It took 2 days to do about 3/4 of a day to do one side and another 3/4 of a day to do the other side. The coring went fairly quickly because of the concrete. Got a video here.
All right, initially when we pull the core, you never know what you're really going to get right away, but normally there's a lot of dry sand. Makes the filter hard to push in at first. So we'll pull the core, let it drain, and then once it starts getting to be kind of watery, kind of lubricates the filter as you put it in the wall. It's easier to seat up against the wall. Now this one's wet right off the bat, so this one will go right in. And once it's seated up against the wall kind of tight, Tim checks the bottom, make sure we're making contact. Then we'll start drilling pilot holes for lag screws. I don't initially torque the lag screws down tight right away. Then we kind of go around it again, tap it with a rubber mallet just to get it as tight as we can. And then I'll just go around again and tighten them until it feels like the screws are tied up against the washers, where the washers won't spin.
I should point out that this crew, this isn't the first installation they've done, so they've had experience with this, but the installation is extremely quick to core the hole and to install the product. So we have an ongoing evaluation. The engineering firm was there for the installation. I don't know if you saw the shovel. He was collecting soil samples from each of the holes to understand what the backfill was when he evaluated, because we used 5 different filter fabrics. and 4 different models of jet filters along our 54 units that we ultimately installed. So he's writing his report, and he's going out every few months to inspect a few of them of the different fabrics and evaluating the flow rate that's coming through after if we have a long rain, short rain, what the conditions are. And he's evaluating the flow rate and opening them up to check to see if there's any clogging starting to form on the different fabrics. As you can see, this was in the beginning, but the water had drained. You can kind of see it here and in the next picture. The water had started to drain very quickly. This was a crack where water was coming through all the way up to the ceiling. So the water level was dropping within the first 24 hours, basically. You can see that this was after a heavy rain. The crack was no longer the easiest path. It was now the filter. So he's taking water samples. The day they were installed, right after the installation, the samples were pretty cloudy. This actually happens to be a non-woven fabric. The woven fabrics were a little bit better a couple days later. And then on September 14th, he went back and collected samples from all 5 filter fabrics, and there was no sediment coming out, even though there had been a significant storm event the days following. And all the filters were draining, but the soil filtration was working. So our next steps, we're going to continue to monitor this and report out. The engineer's already written a few reports that haven't been published yet, but we're going to work with them and Michigan DOT to finalize those reports. We're also looking to identify other DOTs that are interested in doing an ITD project with us. We'd be very happy to come to your location, do an installation with you, educate, and evaluate. The reason we're doing this is, as I said in the beginning, we're kind of an unknown product. And we need to get out there and get education going and get implementations that are done by DOTs that can actually record and show our performance.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.